Today we're solving systems, that means more than one, of linear equations and quadratic equations, which means we're going to have two equations overlapping. What does a linear equation look like, or linear graph, a linear function? Straight line. What does a quadratic look like? A U shape. Is it always opening up?
Well, no.
No, it could be opening down. All right. At most, how many solutions do you think we could have? This is us brainstorming. If I have a parabola like this and a line like this, at most, how many solutions? Solutions are where they intersect. Two. Two is correct. Do you guys see that? Do you think I'm ever going to have more than two solutions with a straight line and a parabola?
No.
All right. Could I have less than two?
Yes.
Is it possible to have one?
Yes.
What would it look like for the parabola and a line to only intersect once? The line's going straight down like this? That is correct. The only thing is that's not a function. So if it were to be written as a function, it would be going straight like that. Got it? All right. Or even slanted just a bit, but it's hitting it only once. All right. Is it possible to have one with no solution? Yes. Does it matter again if the parabola is opening up or down? No. All right. And then I have a line maybe like this, and it never intersects. So this one is two solutions. This one is one solution, and this one is no solution. All right. We are going to solve these two different ways, by graphing, please stop, gentlemen, and by actually solving algebraically. All right. So first piece we're going to graph. Find all solutions to f of x equals g of x, period. Solve by graphing, period. Solve by graphing. Find all solutions to f of x equals g of x. F of x equals g of x when they intersect. You guys understand that? Yes? The point of intersection is where they equal each other. So we're looking for when a quadratic equals a linear, and we're going to do that by graphing. Number one. F of x equals 2x squared plus 1, and g of x equals negative 2x plus 5. Write those down. Yes.
Does it matter? Like, I thought f of x meant it was like a linear.
No, f of x, good question. F of x means it's a function of x, and g of x just means it's a function of g. And both of these are functions. Did you guys learn last year how to test if a graph is a function by doing the vertical line test? Did you guys do that last year? Do parabolas pass the vertical line test? Yes? Do linear graphs pass the vertical line test? As long as the graph is not vertical, which is what somebody had brought up earlier. All other linear graphs do pass the vertical line test. So as long as they're both functions, which they are, we can call them f of x and g of x. All right? Questions? As we are graphing, is we are going to be making t-charts. And you will have... No, I know. I'm trying hard. Thank you. I'm going to do two separate t-charts, one for my f of x and one for my g of x. All right. X comma f of x and x comma g of x. What's another letter we can use for x of x or g of x? Y, which is why I'm putting them in the y spot. Why am I calling it f of x and g of x? So I can keep track. Put your phones away. So we can keep track of which function we're using. All right, where I suggest and would like you to start is using your function, not always your f function, but always your quadratic. Always use your quadratic. We will be graphing it in just a little bit.
Wow. I thought you were like trying to solve it or something. But yeah,
We-
just all came back.
Okay. All right. Make your graph paper similar to mine. Go ahead and do that now. All right. So, gentlemen, I need you guys listening. Start with your quadratic function and think of what we know about shifting. We know the parentheses tells us the right-left shift. Gentlemen, need you listening. And the outside number tells us the up-down shift. Is there anything in the parentheses?
No.
So am I shifting right or left? No. How far am I shifting up? 1. Start with your vertex. Do you agree that's the vertex? And which way is it opening? Do not graph it because we need to be specific with our points, but we know it's opening up. Yes or no?
Yeah.
All right. So what you're going to do, what x value is this right here? 0. And this is the f. So you start with 0, and you're going to graph 2 points to the left. I'm sorry, 3 points to the left and 3 points to the right. 1, 2, 3. What is that? Okay. What's this one? -2, -1. Do you agree? -3, -2, -1, 0. And then what would be the 3 to the right? 1, 2, 3. All right. So what do you do first? You find your vertex. First, you find your vertex. And then how many in each direction once you find your vertex? 3 to the left and 3 to the right from your vertex. All right. So how did we find the vertex was, what is this vertex, by the way? 0, 1? How did we know it was 0, 1? Because it does not shift right or left because there's no parentheses, but it shifts upward.
So outside, anything outside to the
Is-
the exponent
Is the up, down.
is up down.
And anything
so like, let's say
inside.
it was like +3 would be
They've up 3.
Now
All
what
right.
if it was like +2 times?
We'll see those in just a little bit. Guys, I need you listening. Does this 2 at all have any impact on our vertex? No, it's just how wide or thin it is, and that's not going to impact my T-chart right now. All right, plug in -3 to the f of x function. What's -3 times -3? 9 times 2? 18 plus 1? That's too big for my graph, so I'm going to continue. -2 times -2. 4 times 2 plus 1? 9. Now, when you're doing this on your own, you may go a little slower, you may go a little faster, and you may show more work than I am, but we're running short on time, so I'm going to continue.
Yeah.
Plugging in -1. You square first. What's -1 times -1? Times 2 plus 1? 3. I'm going to go ahead and plot those really quick. -2 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3. And then I haven't plugged in 0 yet. We know it should be 1, but we're just going to test it. What's 0 squared? Times 2
Okay.
plus 1. Did we end up with the 0, 1 like we said we would? All right, plug in +1. What's 1 squared?
I get it now.
Do you?
I was confused because I was like, wait, how is she getting 19?
Oh, okay. All right.
But now this is
Not
is
that
like-
bad.
This is like stuff I didn't know.
Good. What's 1 squared? 1 times 2 plus 1. Next one, what's 2 times 2? Times 2? 8 plus 1, 9. I'm going to graph those. 1, 2, was it 3? Did I graph this one wrong? The negative 1, 3, 1, 2. I just didn't go up high enough. All right. 2, 9. And then 3. What do you guys think? Looking at the pattern, what is the 3 going to come out to be? 19. And it does. 3 squared is 9. 9 times 2 is 18. Plus 1 is 19. Do we have to graph that point? No. And then you just put your arrow. All right. Should feel like review? Yes or no?
Yeah.
All right. Next one. We're going to use the exact same chart we did here. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. You're always going to start with your quadratic, figure out these numbers, and then use the same set of numbers for your linear. I'm going to repeat that. Gentlemen, stop. Which function do you start with? Quadratic. You figure out your numbers you're going to use, and then you use that same set for your linear. Okay, this one should be a little easier. What's negative 2 times negative 3? This is where I'm at. Negative 6? Positive 6? Which one? Positive 6 plus 5? 11. Negative 3, 9, 10, 11. Is that a point of intersection, yes or no? No, we can see it doesn't match. All right, negative 2. What's negative 2 times negative 2? 4. What's 4 plus 5? Is that a point of intersection? Did it work?
Yeah. So that should be exactly matching?
Yes, so that right there is a point where they intersect. All right, next
So what
one.
if it was,
Well, let us continue before. All right, so negative 1. What's negative 2 times negative 1? 2 plus 5? Did those two match up? No, but we can still graph it. Negative 1 up 1, 2, 3, 4, 5, 6, 7. All right, 0. Negative 2 times 0? Plus 5? Does that one match? No. 0, 1, 2, 3, 4, 5.
okay, never mind.
1, 2, 3, 4, 5.
Oh.
All right. 1. Negative 2 times 1.
Teach for fun.
I don't know. You're going to give me. Can you just take it for now? Yeah. All right. What's negative 2 times 1? And negative 2 plus 5? 3. Is that one a point of intersection? Do they match? 1 and then 1, 2, 3. I'm going to color that one in. And then let's just continue. 2. Can you guys do that quickly?
You don't need to do the, on the test, do you want us to do the last two?
Yes.
Away?
Yes. This is 1, and this
Even
one
though
is...
It's not going to be more than 2.
No, even though, because we need to graph it. So 1, 2, 3, negative 1. Now, because we're doing it without graph paper, the linear graph is not going to come out looking very linear-ish, but we try our hardest to make it look like a linear graph. That one looks like it's off. When you have graph paper, it's going to come out nice and pretty, and everything's going to match up on the graph the way it should. All right, what are the two x values at which they intersect? X equals what two values? Negative 2, and what's the other x value? What's the other x value? 1. All I need are the x values. If you write them as ordered pairs, that's okay, but you don't have to. All I need are the two x values. The negative 2 and the positive 1 is where they intersect. Does that make sense?
So,
Yes.
all you have to do is, so how did you start, know to start off with negative 3? And
I'm going to go over that on the next one again. Number 2, f of x equals x minus 6, g of x equals x minus 1 quantity squared plus 7. All right, which one am I going to start my t-chart, the quadratic or the linear? Quadratic is where you start making your t-chart. So when I make my t-chart, I'm going to call this x, and I'm going to call this g of x. And on my other one, I'm going to call it x and f of x. And I always do the quadratic first. All right. Do you start at, no. I'm going to shift this down just a smidge.
And these notes are going to be on
Yes. All right, so let's find our vertex form. Let's find our vertex first. What is our vertex? Opposite, same. What's the vertex? 1, 7. Do you guys see that? It shifts right 1 and up. 1, 2, 3, 4, 5, 6, 7. Do you guys agree? Yes or no?
Yes.
And from the vertex, we go how many to the right and how many to the left? Vertex, what did I say? 3 to the right and 3 to the
that's for all.
left. That's how we figure out the numbers here. All right,
What
what's
is-
one value to the left of 1? Come on, guys. One value to the left of 1 is,
0.
one value to the left of 0 is,
-1.
and one value to the left of -1 is.
Oh, okay, that's how you figure it
Okay,
out.
so here's the vertex. Gentlemen, stop. What's one value to the right of 1? 2. One value to the right of 2.
3,
And the last one would be
4.
4. All right, so what do? You find your vertex by doing your translating over and over 1 up 7, and then 3 to the left, 3 to the right. Yes,
And now all I have to do is plug in
we're going to
1.
plug them in. Guys,
1 for x.
okay.
Or like 0 for x.
So what's -2? I'm going to show a little more work here. What's -2 minus 1? And what's -3 times -3? And 9, yeah, 9 plus 7? 16? Okay, that's too big for my graph, so I'm not going to graph it, but I'm going to continue. I'm just going to erase and keep going. What's -1 minus 1? -2 squared. And 4 plus 7? All right, this one, 0. 0 minus 1? -1 squared. Plus 7? 8. We already said 1 and 7. Let's check it and see if it really does work. What's 1 minus 1? What's 1 minus 1? 0 squared. And 0 plus 7? Does it work? Yeah? Did we get 7? When we plugged in 1, yes or no? All right, plug in 2. Guys, please stop the talking. 2 minus 1 is 1 squared plus 7. Can you guys figure out the pattern? What's the next two numbers going to be? 11 and 16. All right. -2, 16, too big. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 7, 1, 2, 3, 4, 5, 6, 7. We have that one there. 2, 8. 3, 11, and the other one was too big. All right, do we end up with our parabola?
Yeah.
All right, the other function, guys, I need you I'm not talking, need you guys listening. All right, same numbers, -2, -1, 0, 1, 2, 3, 4. Before I continue, does everybody see how I got these numbers right here? What did I find first? The vertex, and then how many in each direction? 3. I need you guys listening. All right, so do you have notes filled in? All right, let's plug it in. What's -2 minus 6? Quickly, guys, right here. We're plugging into the F. -8, is that what I heard? Does it match? All right, -1 minus 6? -7, does that one match? All right, 0 minus 6? Does that one match? Yes or no? All right, 1 minus 6? Does that one match? All right, 2 minus 6? 2 minus 6 is -4. Does that one match? 3 minus 6? Does it match? And 4 minus 6. All right, let's graph and see what's going on. -2 Negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 7. 0, negative 6. 1, negative 5. 2. Shh, guys, please stop. All right, I'm going to start this one over. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 7. 0, negative 6. 1, 2, 3, 4, 5, 6. 1, negative 5. 2, negative 4. What ends up happening? What happens with the line and the graph, the parabola? Do they ever intersect? Okay, did we have an example like that earlier when I showed you just scenarios? No, guys, you guys were not listening. Have a seat. Okay, do you guys agree? So what's our answer here? No what? No solution. No real solution. Any questions? Are we good?
Do we have to graph like every?
Yes, you do have to graph. Guys, I need to hand out worksheets. Are we good here? Okay.